Assalamu alaikum students. Today we will learn how can we sketch the graph by using these things: asymptote, intercept, relative extrema, point of inflection, and also checking the concavity of the function. So before sketching the graph, first of all we need to find all these things. Here the asymptote and the intercept. These are the two things for which we don't need to take the derivative. So what is asymptote is actually asymptote that if you have any graph, so if the graph is keep going with the y-axis, let's suppose you have a graph like this. So if the graph is keep going with the y-axis, then y-axis, this line y-axis is the vertical asymptote of the function. And similarly, if any graph is keep going with the x-axis, this horizontal line is called horizontal asymptote. It means we have to find the vertical asymptote and the horizontal asymptote. It does not mean that all function have both asymptotes. Some function has only horizontal asymptote, some function only have vertical asymptote. So we need to check this one. Next thing, what is intercept? There are two types of intercept as well, x-intercept and y-intercept. When we find the intercept, for example, we are going to find the x-intercept, so we have to put y equal to 0. Means where the value of y is 0, that point of x is called x-intercept. Sometimes a function has one intercept only, sometimes the function has two x-intercept. For example, we have a function like this. So it touched the x-axis at these 2 points. It means x-intercept, there are two x-intercept because in these 2 points y equals 0. So y will be 0 on the x-axis and x will be 0 on the y-axis. So when x is 0, whatever the value of y we have, that will be y-intercept. For example, the graph touched the y-axis at this point. It means this is the y-intercept because on the y-axis x is equal to 0. So whatever this value, that is y-intercept. Whatever these two values, that are x-intercept. Let's check that how to find these asymptote and the intercepts of the function. So first is the vertical asymptote. As I said, the vertical asymptote when the function is keep going to the y-axis. So we need to check that what x value on which we draw a line with the function where the function is keep going to the positive infinite or can be negative infinite. So first we check what is the x value. So look at the function. The function is y equal x square minus 1 over x cube. So at what value of x for which the function is undefined? It can be positive infinite, negative infinite, but it should be undefined. So we know that whenever we have a fraction, so the denominator will be 0. When the denominator is 0, the value is undefined. It means when nx cube equal to 0, then the function will be undefined. And this undefined give us the vertical asymptote. So when x cube is equal to 0, we have x is equal to 0. And we need to check that is this x is equal to 0 also make the numerator 0, because if this value make it 0, we will not take this one. Why? Because otherwise it becomes 0 by 0 form, and that is indeterminate form. For example, you have x is equal to 0 and we have x here as well, so we skip this 0. Why? Because this x and x will be cancelled out. So it means that first of all you need to simplify if we can, and then you need to put the denominator equal to 0. The denominator term where the x, whatever the x value of the function on which the denominator equal to 0, that is vertical asymptote. So vertical asymptote is x equal 0, because it means this is the value of x. So x equal to 0 here, it means at x equal to 0 if you draw a vertical line, so this is a line about which the function is keep going to the infinite. It can be upside or it can be downside. We need to check by finding the other things as well. So vertical asymptote done. Now the horizontal asymptote. For horizontal asymptote, the values at which the function is keep going to the positive infinite or to the negative infinite. So for this, we use that limit when x approaches to infinite and the limit when x approaches to minus infinite. We check that what are the values for which function is going to the positive infinite or going to the negative infinite. So we plug this value into the function x square minus 1 over x cube, and here is x square minus 1 over x cube. And you know that how to plug the limit into the function. When we have the infinite limit, so we take the highest power common from the numerator. So this would be 1 minus 1 over x square over x cube, and this highest power cancel out. When we plug the limit infinite, so 1 over infinite is 0, 1 minus 0 is 1, and you have 1 over infinite, that is 0. And same solving this one by taking the common 1 over 1 minus x squared over x cubed. So even you plug the minus infinite, still the answer will be 0. It means you have two horizontal asymptotes. When x approaches to infinite, then horizontal asymptote is 0. Means this is the x is equal to 0 value. Means when x is equal to 0, the horizontal line is this one. So it means the function will be keep going to the positive infinite or to the negative infinite. So by using the asymptote, we identify two things. Now the next thing is to find the intercepts. There are two intercepts. You have x-intercept and y-intercept. So for x-intercept, we plug y equal to 0 into the function. So what is the function? The function is y equal x square minus 1 over x cube. So when we put y equal to 0, you have the equation is x square minus 1 over x cube equal to 0. And this would give you x square minus 1 equal to 0, and by taking the 1 on the other side, you will have x is equal to plus minus 1. So these are the two values which are x-intercept. Means that on the x-axis there are two values, 1 and negative 1, where the graph touch the x-axis. Now the y-intercept. So when we put y-intercept, for which we have to put x equals 0. So see, we have this function y equal to 0 minus 1 over 0. So minus 1 by 0 is undefined. It means there is no y-intercept. Because y-intercept will be a value of y, but it shows that y is infinite. It means there is no y-intercept in the function. So it does not compulsory that every function have both intercepts. Some have only x-intercept and some have only y-intercept, just like this function. So two things done in y. We have found the intercepts of the function and we have found the asymptote. One thing I need to tell you that this horizontal asymptote is also called ends behavior of the function. Like for example, in any function they ask you to find the end behavior. So you should know that the horizontal asymptote is also means ends behavior. Means that ends behavior means when x is at the ends. And what is at the end? Infinite or minus infinite? Which is the same thing that we check when x approaches to infinite and check when x approaches to negative infinite. So horizontal asymptote is the same thing and behavior. Now we need to find the maximum, minimum, but for this, first thing we need to find the critical points. To find the critical points, we have to find the first derivative of the function. Now these two things we need to check. So you need to understand whenever we need to find the relative extrema or increasing, decreasing, so we have to take the first derivative, and for this we have to find the critical points. And to find the concavity, we need to check the point of inflection. So these two things we need to identify first to find the relative extrema and concavity. But to find these, critical point can be found by taking the first derivative equal to 0, and point of inflection can be found by double derivative equal to 0. So when we use these two things, we need to find the critical. So it means these are the first step, first derivative and second derivative. Then using first derivative, we go to the critical points, and using the critical points, we'll find the relative extrema, means relative maxima and relative minima both. And when we find the double derivative, we find the point of inflection, and by using the point of inflection, we find the concavity. So let's find the derivative of the function. So we have f of x, the function is x square minus 1 over x cube. You are well aware of the formulas of finding the derivative of the function. So as this is a rational function, we use the quotient rule. So after using the quotient rule, the first derivative of the function is 3 minus x square over x cube, and the second derivative of the function after using the quotient rule on this function, that will be 2 times x square minus 6 divided by x power 5. Okay, so we have found these two derivatives, first derivative and second derivative. You can find it using the quotient rule. Now using these derivatives, we will find the critical points and also the point of inflection. Okay, so let's put the first derivative equal to 0. So when f dash of x equal to 0, we have 3 minus x square over x 4 equal to 0. And when we put the function equal to 0, we put the numerator and denominator both equal to 0 one by one. Some students do mistakes that they took the x4 on the other side and multiply with the 0 and only take it 0. No, we have to put the both values, numerator and denominator, separately equal to 0. So this will give you 3 minus x square equal to 0 and x4 equal to 0. And by using this, it will be 3 is equal to x square, and taking the square root on both sides, you will have x is equal to plus and minus square root of 3. And same x4 equal to 0, which give you x is equal to 0. So we have these three values, and these are the critical points. And the critical points will help us to identify the relative extrema, means relative maxima and minima. Now put f double dash of x equal to 0, and the derivative, second derivative of the function is that we found above is square minus 6 over x power 5 equal to 0, and by putting numerator and denominator separately equal to 0, this will give you x square minus 6 equal to 0, which give you x is equal to plus and minus square root of 6, and here x5 equal to 0, which give you x equal to 0. So these are the three values, and which are point of inflection. Point of inflection tells that these are the point where the function change its concavity, positive to negative and negative to positive. That's why point of inflection help us to identify the concavity, and critical points help us to identify the relative extrema. If you notice that we get some points of x while finding the asymptote and intercepts. So we got 3 points, x is equal to 0 while finding the vertical asymptote, and we get x is equal to plus minus 1 while finding the intercepts. So we need, because we need to draw the graph, so for which we will check that how the function behave around these points. So we have 3 points, so we need to check the sign of y, that how the y values behave around these points, x equal to 0, x equal to negative 1 and x equal to positive 1. So when we need to find the sign around these points, for this we take some test points between these intervals to check that how function behave. Next thing, notice that we get 3 more points when we put first derivative equal to 0. So means how the f dash of x behave means we check the sign of first derivative. So for this we again take some test points around these points. So we get 3 points. One is x equal to 0, one is square root of 3, one is negative square root of 3. So we check that how the function behave around these points. Around these points will give us the decreasing and increasing function, and decreasing and increasing also give us the information of relative maxima and relative minima. And when we check the sign of f double dash of x around these 3 points, x equal to 0, x square root of 6 and x square negative square root of 6. So when we take any test points between these intervals to check that how the sign of double derivative behaves, this gave us the information about the concave up or concave down. Because I told you that point of inflection gave us the concave up and concave down, and the first derivative gave us the information about relative maxima and minima, which also can be get by understanding the decreasing and increasing interval. So first we check that which interval is decreasing, which interval is increasing. That help us to identify the relative extrema. I'm going to redraw all the intervals after finding all the things that we have done above: intercepts, asymptotes, and first derivative, second derivative, point of inflections, and critical points. By using the asymptote and intercepts, we identify the sign of y, and that are the values 0, 1 and -1, and we'll check the values around these points. And we check the sign of first derivative by using the points 0, square root of 3 and negative square root of 3. And we check the sign of double dash using the 0, square root of 6 and negative square root of 6. These are the values that we identify above. This is how you find. First you make the intervals. Now we take the test. We take the test points around these intervals. So we have the interval is minus infinite to negative 1, then negative 1 to 0, then 0 to 1, and then 1 to infinite. So from each interval we take a point and check that what is the sign of y. Is it positive or negative? Similarly, one interval is minus infinite to minus square root of 3, then minus square root of 3 to 0, then 0 to square root of 3, and then square root of 3 to infinite. So we take any point from each interval and put it into the first derivative and check that what is the sign of first derivative, positive or negative. Similarly, one interval is from minus infinite to square root of 6, minus square root of 6, then minus square root of 6 to 0, then 0 to square root of 6 again, and then square root of 6 to infinite. So we take test point from each interval and put it into the second derivative and check that how the function behaves by using these points. So let's take any point within the interval. This is -1, so let's take -2 from here. Between -1 to 0 you can take minus negative 0.5. Here you can take 0.5, and here you can take, let's take 2. And you take, these are just test point. You can take any other points, but it should be within this interval, within this interval, within this interval, and within this interval, and plug into the function y, because we have to check the sign of y. So x square minus 1 over x cube. So plug into these function one by one from each interval and check that what is the sign. So this is what you need to check. Okay, you can identify by your own. I can tell you that when you take any point from this interval, this will give you negative. When you take any point from this interval, the answer will be positive. When you take any point from this interval, this will give you again negative, and when you take the value from this interval, that will give you again positive. So this negative positive give us the information that how the value of y in this interval, the value of y will be negative, here will be positive. These help us to make the graph. Okay, now for this, so we need to check the sign of y dash. So y dash, we know that the y dash is 3 minus x square over x power 4. So plug into this function from each interval. So square root of 3 is approximately 1.73. So this would be negative 1.73. So you can take any point which is less than this. So let's take it's minus 2, and between this and this it could be minus 1. You can take 1 from here and you can take 2 from here. So after taking the point from each interval, you will notice that the sign in this interval will be negative. In this interval, the sign means whatever the value of y dash will get, that will be positive. Value does not matter, the sign matters. And the value here, it again positive, and the value here, it's negative. What this information help us? This actually help us to identify that negative means this is decreasing interval, positive means it's increasing interval. If this positive means again increasing interval, and this negative means again decreasing interval. Okay, so it means from minus square root of 3 to square root of 3, the whole interval is increasing interval. After that, it's again decreasing. So where the function change its sign, that give us the maximum or minimum. Just like here, from negative to positive, the function is changing from negative to positive, means decreasing to increasing, means here the function decrease and then increase. So at this point, the lowest point means it look like this, going down and then going up. So it means here the value at this, so this point is actually the relative minima. Relative minima means here you get the value is at lowest point. So when the sign is changing from negative to positive, so the point around which you are checking, that point is actually relative minima, not the interval. Interval is increasing and decreasing, but when you need to tell that what is relative minima, you have to tell that at which point you have relative minima. So relative minima at minus square root of 3. Similarly, here sign is positive to positive, sign is not changing, so there is no maximum and minimum here. But again, positive to negative, sign is changing, means first is increasing then decreasing. So at this point, this is relative maxima. So see, by using the first derivative only, we identify two things: decreasing intervals, increasing interval, also relative minima and relative maxima. Next thing is, by using the double derivative, what thing we can identify? So you plug the value from each interval. Square root of 6 is almost 2.45. So this would be negative 2.45. So the value from here, let's take minus 3. Let's take the value here is minus 2. You can take 2 here and you can take 3 here. So by using these points from each interval, the sign will be changed when you identify the value of the second derivative, and you would check that the sign. So you would notice that on this interval the sign is negative, on this interval the sign is positive, on this interval the sign is again negative, and on this interval the sign is again positive. It means the sign is changing. So where the sign is changing on these point of inflections, that give us the concavity. So when the sign is changing from negative to positive, means negative means there is concave down, at this point it's concave down, and when positive it concave up. Same, positive to negative up, and here is concave down, and here is again concave up. So this help us to check the concavity of the function by using the second derivative, which is the function is 2 times x square minus 6 over x power 5. So you will plug these points from each interval into the second derivative, which give you this information. I explain you these values here, but you need to plug each value onto the function. The easy way to make not so much mess up in the paper. So what do? You make the table. Make the table like this. Here you write x values, here you write y values, and plug these values just like in this interval. So you are using -2, plug here, then minus 0.5. So you can use find by calculator and write the answer here, then 0.5, then 2. So and then write the sign in front of this will give you negative, this give you positive, this give you negative, this give you positive. So this will not make so much mess in the paper, because otherwise if you write each point and solve on the paper everything, so that will make so much mess. Similarly, you make the table here of this one, x values and y dash value here. So whatever the x values you are taking from each interval, plug it here and write their answer here, which give you the negative, positive, negative, positive. And same for here. So it's easy to manage everything on one paper. Now I have summarized all the things that we identified: asymptotes, intercepts, and all these things that I just explained you. But one thing is the point where we get relative minima and maxima. These are the x values at which the relative maxima and minima exist. But at these x values, what are the y values? So let's find that. When x values is negative square root of 3, so when we plug into the function y, so negative square root of 3 is minus 1.73. So by plugging this value, we will have negative 0.38. Similarly, when we plug square root of 3 into the function, that will give you 0.38. And the point of inflection that we find, so also we have to plug these functions here. So when it is square root of 6, which is 2.45, so at these points the function value is 0.34, and when it is negative square root of 6, the function value is negative 0.34. Because these are the critical points and point of inflection, that's why we have to plug into the function to find that what are the y values. Okay, so let's plug all these values into the function. First point is negative 1.75, negative 0.38. Okay, so first point is negative 1.73 and negative 0.38. So negative 1.73 around here and negative 0.38 will be down here. So let's see, the point is here. This is the first critical point. Second critical point is 1.73, 0.38 above, like here. Okay, so similarly, next first point of inflection, which is 2.45 and 0.48. So x is 2.45 around here, sorry, 2.45 around here, and the value of y is 0.34. It's less than above, like here. and negative 2.45 with negative 0.8, it's around here. It means the function will be going down here, same down here, up here. Okay, we identify this. Next is, we know that asymptote at x is equal to 0, this is a vertical asymptote. It means function will be keep going with the positive or with the negative y-axis. Now let's draw the intercept. So intercept means function will touch at minus at 1 and at minus 1. Function will touch the graph x-axis and y-axis at 1 and minus 1 because these are the intercept. So see, function touch here and also that function going here, and it's showing the y-axis. Let's see that how, where we identify the points. Now we need to check that function will going upside or downside here. So we identify this by using these curves, these values that we identify. So between 0 to 1, 0 to 1 function is negative. So function is means going down, and then from 1 to 2 function is upward. Of 1 to infinite, so function is upward, all is upward. Similarly, minus 1 to 0 is function negative, minus 1 to infinite, all function is negative, but 0 to 1 it's positive. So 0 to 1 function is positive, means upside. So it's upside here and then here. It's down here and here. So this information gave us the function is. So it means from minus 1 to 0, it will be upside here, and 0 to minus 1, it will be down here. Okay, so function down here, and here is upside here. Going up and it's going down. Okay, next is, let's check the concave up and concave down, and also increasing, decreasing. So between 0 to square root of 3. Okay, so we have mark the square root of 3 point. This is a square root of 3 point. Okay, so square root of 3. So from 0 to square root of 3, 0 to square root of 3 function is increasing. The interval is increasing. From 0 to square root of 3 function is increasing. Increasing means going upside, and then after that it decreasing. So we, by using the y values, as we notice that the function from at 1 it touched the graph, here at negative 1 it touched the graph, and between 0 to 1 it's down, and then going, it's increasing and then decreasing, and then it's going to the asymptote, horizontal asymptote. Same, this is decreasing and then up, concave up, and it's keep going with the horizontal asymptotes. Here you notice that at square root of 6, this is concave down, this is concave up, concave down and concave up. See, at this point concave is down, then concave up, same concave down and concave up. This is the graph of the function. What you need to draw first? First you draw all the points that you have found here, critical points and concavity, point of inflection. But remember, critical points are the x values, so you have to find their y values. Same, point of inflection are x values, you have to find their y values and draw these points. Then you have to check their positive, negative, concave up and concave down, and then draw the graph. Because it have the vertical asymptote, so that's why we cannot cut this one. Its vertical asymptote means it's keep going. Vertical asymptote and keep going. Why it writes down? Because on these interval it gave us the negative, so it's going negative. And on these interval it gave us positive, so it's positive. And after that it's negative, so it's negative on the negative axis. And before After that, this is positive, so it's positive. So according to this, I draw the positive negative. According to this, I notice the maximum minimum. See, this is maximum point, this is minimum point, and here is contained down, up, down, up. So this is a whole graph, and these are the points that we identified to make this graph. I hope you understand. You can practice more questions related to this. You can try by your own. And remember, only these are the points that you need to identify, whatever the function is. Okay? Function can be any type of function, but you need to notice that what are the things that you need to. Thank you so much.